Hello guys, welcome back to Tronics Energy. Now last time we did a forward reverse method of starting a motor, and I tried to demonstrate it in the breadboard using a very simple circuit. Today we are going to do a star delta motor starter, and I've made a circuit. I've designed a circuit to kind of replicate what really happens in the real world application. Now, as you may know, star delta motor starters usually start with a star connection, then shift to delta automatically using a timer. Now that's what our circuit is going to do. If immediately I press start, starts in star, then goes to delta. And the difference between star and delta, as you may know, is the speed. The speed at which the star is running is slower as compared to delta. You can see the delta is going at full speed. So that's what we're going to discuss today. Now the circuit is very simple. It's just what we have been looking at, only that this time around we add other things. Like this front part of the circuit is just the same as the DOL and forward reverse, only that here we add what we call the timer. Now this is the timer. This is the timer right here. So immediately I press start. Immediately someone press starts, the contactor. Now here we have three contactors. We have the main contactor, the contactor for delta, and the contactor for star. So immediately I press the start push button. It's going to power this coil, and also this coil, from it we tap it, and we also power the coil inside the timer. The timer has a coil inside. Now the timer has several pins. We have 8, 7, 2, 5, 6. Now the 7 and 2 are the ones for coil. 8 is a common, and we have 5 and 6. Now from the common, inside the timer we have an NC connection and we have an NO connection. Since we want to start with the star, we are going to connect the NC to the star coil, and we are going to connect the other NO to the delta, which will come later after the timer has finished counting. Now immediately you press start and the timer is powered. It's going to start counting immediately, and this connection will stay on up to the counting, and when the counting has stopped, this becomes NC, this becomes NO, this is powered, and the delta picks on from that point. And this bottom part here is what we have been doing. I hope you understood. This is what we did last time. It's what we call an interlock. We have the Y contactor coil here, and we have delta contactor coil here. Now they are not powered directly using the auxiliary. The auxiliary contact which is powering this Y coil comes from delta contactor, and what powers this coil for delta comes from an auxiliary contact of star, and this prevents them from being powered at the same time, which is going to cause short and damages. So this is so this is the diagram, and here we have a simple diagram to show what is the real difference between the star and the delta. For the star, each coil inside the motor in the real world application gets around 240. So it means that it's going to be less as compared to delta, which each coil gets 415. So meaning that delta runs at a much greater speed as compared to the star connection. And that's what really happens in the circuit. So immediately, so when I press start, this is just a simulation, just a circuit that I've designed to do what the star delta really does in the real world application. So immediately I press start, starts in star, then you can hear delta is goes a much more speed as compared to star. So we do that again, star, then shifts to delta, and so the circuit is very simple. If you want to make this very simple, so you just have a timer using any 555s. We have a monostable here, which is the one powering the rest of the circuit. This enables us to get control, to have the control of the full circuit. If I press this stop, it shuts down everything. So that gives us the power. Here we have the NE555 in monostable mode, which is powering another NE555 in astable mode, giving a PWM PWM signal, which is a pulse width modulation signal to the L298 driver. So when the star starts, the star gives a PWM signal to the L298, which drives the motor at a lower speed. Then when the timer stops, this NOT gate, which is detecting that immediately the timer stops, it's going to give a signal to this transistor right here, which we have connected the jumper, which is normally used here to connect these two pins once we want to run the motor in full speed. So immediately this gets power, it means that we have connected these two parts, and the motor runs at full speed. So that's basically what is really happening here. So that's what I wanted to show you guys today. This is a Star Delta motor starter. If you have any questions, you can still ask. I'm here. I'll be glad to answer you. And yeah, like that.